And so here we are in the storage portion of making an EC2 instance. I'm going to hop over into the AWS console, and I'm just right where we left off in step 4, add storage. So far, we've selected the base image, so the template for our server. We chose its power levels, so CPU, memory, and then also the family type. We selected from the T2 family, we selected the micro, so we're using a T2 micro. And then we configured all the details and options about our instance. But during this process, we haven't addressed storage, so the hard disk space. And unsurprisingly, that's what add storage is all about. So simply put, just as we attach storage to our own computers, we have to do the same thing for EC2 instances. And when we attach a volume, which is what these are called, volumes, to our instance, it shows up just like any other hard drive or physical device that you plug in. And once it's attached, you interact with it with just like anything else. And by default, depending on the Amazon machine image you select, the Amazon machine image that you select will have the requirements of what storage is needed absolutely just to get whatever's on it up and running and working. Because if we had no storage, well, it'd be like trying to use a computer without a hard disk. That wouldn't be very useful. Now, before we dive into the various details of what a storage device is here, so adding a volume and what all of these columns mean, we need to talk a little bit about the volumes on AWS. And what AWS calls its hard drives that you attach to instances, it calls them EBS volumes, so Elastic Block Storage volumes, because they're volumes for block storage. So things like operating systems and the like. Well, before we go deeper, I need to explain something that's very odd about EC2 instances, and yet quite interesting once you get it down. So let me hop over to my images here, and I've made a great picture. So when you buy a normal computer, you go and you buy one from Best Buy or whatever store, the networking capabilities, the compute ability itself, and the storage tend to all come in one package. With an EC2 instance, though, that is not the case. EC2 instances are actually 3 different pieces. There's the Elastic Network Interface, which is just how the ability to connect to a network. There's the Elastic Compute, the actual instance itself, what we think it is, the CPU, the memory, and the like. And then there's the Elastic Block Storage, which is the hard drive. And AWS actually keeps all 3 of these things separate. And the separation allows for a lot more flexibility. So let me hop back over. So we see the storage here, but what about that network device? Well, the reason we didn't see that, if we just go to previous and we're in the configure instance details, you won't see that if you leave subnet as no preference. However, if you select a subnet, it will then list the network interface down here, the subnet, and the different things about it. But we're not going to get too deep into that because that takes us into the realm of VPCs. So let me change this back to no preference and go back over to next add storage. But the reason that's important to understand is because it shows just how flexible EBS volumes are. We can have a volume for this instance, and then maybe we can terminate the instance later, but hold on to this volume and attach it to a different instance. And so this is always a way that you can scale vertically or even horizontally, in the sense that you can have a server at a very small level. It's got all of its configurations, it's got different data on it, and then you realize you need more compute. Well, instead of having to spin up a whole new server and add everything you've done again and replicate stuff over, all you have to do is get rid of the instance part and save the storage, so detach it and make it so that it's just separate, make a new instance with the new levels of compute that you need, and then just reattach the old volume you were using on the other one. And that's the flexibility that you get from having these things separated. Okay, so now with that knowledge in our heads, we can go ahead and start talking about individual volumes that we can add to instances. So we can see here that one has already been specified for us. It's the root volume. Now, it's the root volume because it has all of the stuff on it we need for this instance to even work. So we need this volume here so that we can load the operating system, install packages, and the like. Now, volume type is root in the sense that it's saying root, and the reason why this doesn't say EBS here is because we can't get rid of it. We need this. But if we add a new volume, you can see the only option here is EBS because it is the only option. There used to be a different type just called instance where it would just store everything on the instance itself, but AWS has since moved away from that. And now the only option is to use these detachable and flexible EBS volumes. So that's the volume type. When you move over to the device, this is a Linux type thing. This is just what path this volume is available at. Well, if you're familiar with Linux at all, they tend to cycle through what they call storage devices as SDA, SDB, SDC, and the like. And so we have this root one here with a special XVDA, but if we added a second one, it would just put it at SDB. So there's that. For Snapshot, well, Snapshot is something we can do with EBS volumes. We can take a point-in-time snapshot of a volume, get its exact state, and use it for later. And by use it for later, I mean if we need to replicate this instance, we need more of it, well, we could just take this snapshot and restore multiple instances from that snapshot. Of course, the big win of a snapshot is disaster recovery. You know, if this goes down, you've got a snapshot there, then you can restore from it and you're good to go. It's not a lot to the snapshots there. We won't actually use or make any. So for size, well, out of all of these here, this is the simplest. Just how big do you want the volume to be? Now, one thing to keep in mind, and it's not immediately obvious, is that the size of the volume impacts the performance. And by impact, I mean the bigger the volume, the better performance. And by performance, I mean the IOPS, the input output operations per second. So how fast can this hard drive be read from and written to? Well, the bigger you make it, the more you can do. But every EBS volume, regardless of the size you give it, always starts, well, the general purpose, and we'll talk about the volume type here in a second, but every single one of these volumes begins with a baseline performance of 100 IOPS, so 100 input-output operations per second. But as you increase the volume size, so if I say make this 80, we can see that the IOPS go up. And if I make this 800, well, we can see the IOPS really go up. And so as you boost the size, not boost, but as you make the size of your volume bigger, well, you're going to get more performance. So it's just important to keep that in mind. And we'll talk about that here shortly, a little bit more about IOPS once we get through this next section, which is volume type. So for volume type is... As a consumer, you know that more than likely, since you're in tech, the difference between an old school magnetic hard drive, so a disk that spins up, and an SSD, a solid state drive. So the type of hard drive you find in modern mobile phones. So like in an iPad, just how much snappier and faster it is. Well, you get to select from a variety of different types here. We have general purpose, provisioned IOPS, cold HDD, throughput optimized HDD, and magnetic standard. And we're going to go ahead and just walk through all of these types so you're aware what's available to you. So let's begin with the general purpose SSD volume type. Now this is going to be more than likely the most common volume you work, and it's a solid state drive that operates on a burstable model. That's right. So it works a lot like the T2 and T3 family. In fact, it works like them so much that I just repurposed the slide to demonstrate it. So here we are taking a look at my wonderful artwork here. The analogy here is that a general purpose SSD operates a lot like a car with turbo boost. The car has a base speed of 20 miles an hour, and it can go turbo for 80 miles per hour. And when it goes turbo, it expends fuel to do so. When it's not using the turbo fuel regenerates. Well, with general purpose solid state drives, they have a base IOPS, and we talked about that a little bit already. But then they also have their full burst IOPS, like how fast can it go when it really wants to? Well, for all general purpose SSDs, that burst is up to 3,000 IOPS. And how long can it go? How long can it hold it? Well, it depends on how many credits it has. Well, every general purpose SSD that you make is going to start with 5.4 million credits that you can use to burst up to that full 3,000 IOPS. And in terms of, well, how many credits does it earn back when it's not being used? That's going to vary based on how big you make the volume. And just like with everything else, the bigger the volume, the more credits you get. Now, my one complaint about the way they decided to take the way that they use this burst model is that the credit system isn't as clear. So with the T2 family, it's very simple. 1 CPU credit equals 1 full minute of full CPU. Whereas in for the SSDs, there's nothing that one-to-one. Instead, we just get in the documentation that everything starts with 5.4 million credits. And by the way, 5.4 million credits only equals 30 minutes of full performance. So calculating these is a little less straightforward because the amount of credits you're going to get back is going to be determined by how big of a volume you make. And its baseline performance is also going to be determined by how big of a volume you make. And we already looked at that a little bit when we were tweaking the size of the volume. But for the most part, you can think of it in that same burstable model. You can think of it in the same way as we thought of the T2. And the reason that we do it like this is because when you launch a server, it's the same reason. It may not have constant read and write going onto the drive. And if that's the case, you don't need a high baseline. You just need to be able to burst to it when you need it. So there's general purpose. Let's hop back over to the console and look at the next option, the provisioned IOPS SSD. So this is an SSD. But the difference between it and the general purpose is there is no burst model. Whatever you specify as the IOPS is exactly what it will be at all times. This makes this perfect for things like databases, for behind web services that you need to make sure are always up. So that's provisioned IOPS. It's quite straightforward. And this takes us, and by the way, provisioned IOPS, as you can guess, does cost more. So this brings us to the hard disk drives, the HDDs down here, these next 3 options. And so we have 3 options here. The first one is the cold hard disk drive. And the cold hard disk drive is the slowest. It is for data that you do not access frequently. So if you just need a ton of storage for maybe old data that you may need to come back to later, or old log files, or any use case for that type of a scenario, the cold hard disk drive is a great option. Now, immediately, one of the things you'll notice is that our IOPS go away, and suddenly we're looking at throughput in megabytes. And by throughput, meaning just read writes to the actual drive itself. And this is because when you look at the hard disk drive options, AWS doesn't use IOPS as the metric, and it doesn't use IOPS as the metric because they're pretty low. So to make it, I assume, to look like more, and because it is a better measure, the measure for these cold hard drives is instead throughput in megabytes. So that's the only reason that changed. And once again, that throughput, just like how the general purpose SSDs IOPS are based on the size, well, if we increase the size of this cold hard disk drive, we'll see that the throughput will also go up as well. You will notice, though, over here under throughput, we have the little division here, the slash thing, and that's because much like the general purpose SSD, the cold hard disk drive does operate on a burst model as well. It has that baseline throughput, and then it has the burstable throughput. And it also accrues credits that can be used towards hitting that top level performance. So that is the cold hard disk. Let me change this back down. The next one is the throughput optimized hard disk drive. Now, the throughput hard disk drive is much like the other one, except it's intended for throughput intensive workloads. So if you want to keep cheap storage, but if you also need to run a lot of analytics, if you need to stream a lot of data, maybe for just, older business data that you're running analytics on or something like that, where performance and frequent read writes isn't a big issue, well, the throughput optimized hard disk drive is what you want to take a look at. And it operates on the burst model as well. So if I sit here and add more size, we'll see that throughput is much higher. The burst performance is much higher than is, say, the cold hard disk drive. And so that's all there is to the throughput optimize HDD. And then the final option is called magnetic. And the magnetic is more or less, I wouldn't say deprecated because it's still in use. And you can still use it. However, it is the previous generation of these two here. So you really, if you really just need a hard disk drive, you really just want to pick one of these two. Now, the reason why you would pick magnetic, when would you ever pick magnetic? Well, it's if you need it to be the root volume. Throughput optimized hard disk drives and cold hard disk drives cannot be the root volume. And you can see this if you do the drop down for our root here, we don't see cold or throughput on this list. And so those are all the different options available to us. So I'm going to actually get rid of this entire thing here because we don't want an extra volume. But if you did, and I certainly don't want 800 gigabytes, but if you did want another drive, if you wanted another disk drive hooked up to your instance, you would just keep adding these volumes here. So there we go. That is, let me get rid of that, the volume type. And because we've talked about volume type, we talked about IOPS and the throughput, which is only relevant when you're looking at the magnetic or the hard disk drive ones. So this leaves us to two very simple things. The next one is delete on termination. And this is very simple. When you get rid of your instance, when you terminate the instance and say, hey, AWS, I don't need this anymore. What do you want to do with the storage attached? Well, if you have delete on termination, they're going to get rid of it. But if you uncheck it, they'll keep this volume around. They'll keep this volume around. And just specifically, let me open up a new tab here in EC2. Under volumes, so we can see right here the volume we have attached to that first instance that we made. And we see there's another one here, I assume from one of my older instances, that's just hanging around that's available. Well, if we leave this unchecked, if we delete the instance it's attached to, it'll hang around and we can use it for other things. But I am going to leave it checked there. And then finally, we get to encryption. Well, encryption, if we choose to encrypt a volume, the first thing we have to do is select what encryption key we want to use. So we see they have a default encryption key that they give us, and we see we have some other keys in here from my workshop and some different things that I do. And when you pick a key to encrypt, what it'll do, well, it'll do a number of things. The biggest thing is that it will encrypt the data on the disk itself. So obviously, that is a huge win, but it'll also encrypt all of the data that moves between the instance itself and the volume. So you get that nice security, that nice extra added layer of security, and there's no real effects on latency or performance. Now, of course, the only downside to this, so if we decide to encrypt this one, we select that encryption key there, is that it costs more. So KMS, so the key management service, is another service inside of AWS, and it's what's responsible for managing those different encryption keys and using those encryption keys. And the way that they charge on KMS is it's 3 cents for every 10,000 requests to use the key. So just be aware that if you do decide to encrypt, it is going to incur additional costs. I, however, am not going to encrypt this. Alrighty, and that brings us to the end of storage. This was a longer section, and there is a great deal. I did want to point you to the volumes documentation, not the volumes console. Specifically the pricing, so that you can see the pricing. It's just EBS/pricing. And on here, you can get some estimates of how much these different drives cost. And instead of charging you for multiple things, the pricing on their volumes is actually very straightforward. And their pricing is just, how big is it going to be? However big you make it, that's going to be what you pay for most of them. Outside of provisioned, where you also pay for the amount of provisioned IOPS that you select. So it's not too bad. And then, of course, there's this page here, this link that I'll put under the video. And this goes in depth into every one of the volume types, how they work, how the credit balance works. There's quite a bit to it. It's pretty involved. So you can take a look at that at your convenience. Okay, let me hop back over to the correct page here. And with that, that will take us to tags and security group, which is what we will talk about next.